Hello again, it's me, Glenn Joshua, your tutor for data structures and algorithms. So for our next lesson, we will be discussing about stacks and queues. So let's begin. So a stack is a data structure of ordered entries such that entries can only be inserted and removed at one end, which is called the top. A stack is a last in, first out data structure, and there are two ways to implement a stack using array or a linked list. So, an easy explanation for stack is the stacking of, I guess, rice, the stacking of rice bags or rice sacks, because when you stack rice sacks, you start at the bottom and then you build it up, and then if you want to get one, you have to pick up the first one because it is much easier than that. And I think you really can't get the middle one unless you want the other two to topple over or fall down. So you have to get one on the top. So that is how stack is implemented, or how stack works. So these are the stack operations. So please note that those that are in red are those that are changed. These are your stack name or the values that you want to push at the top of the stack, while the black ones are the syntax for the stack operations. Okay, so first you have the stack and stack name. This one declares your stack variable as stack, and then creates stack name. Oh, don't forget the underscore. It creates a new empty stack, and then here the pop, top, and push. So the pop stack name, let's say sack. It removes the first item from the stack. Please note that you can only pop what's at the top. Okay, remember that you can only pop what's on the top, because you stacks, from what I've explained, is that you can only remove what's on the top. It is a last in, first out method. Alright, then next you have the top stack name. So this one returns the first item from the stack without removing it. So it just gets its value, but it doesn't remove it from the stack. And then lastly, push, and then the item, let's say the number 7. So now 7 will be pushed at the top of the stack. Okay, and then next you have init stack. So it creates an empty stack, and then lastly is the is empty, and then the stack name. So this one checks if it is true if the stack is empty or not. So here we have an example of a stack, and let's do it together. Alright, so this is an example of a stack. So here we have the stack S. Let's make that one. So this is how it will look like. S. And then X has been initialized with a value of 2. And Y has been initialized with a value of 3. So the first one is S push X. So the value of X is 2. So let's push that 2. We have 2 here. And then next, S will push the value of 2 times Y. So the value of Y is 3. So 2 times 3 will be 6. So let's push that at the top. And then next, S push the value of 4. There we go. And then Y will take the value of S pop. So the top is, so the top of the stack is 4. So that will be pop, and Y will take its value 4. Next to that, S dot push 7. So 7 will be placed at the top of the stack, and then S dot pop 7 will be removed at the top of the stack. Next is X will take the value of S dot top. As we've discussed, the top only peaks the top of the stack, and it doesn't remove it from the stack. So the top of the stack at this point is 6. So X will take the value of 6. Okay, and then next we have here 4 int I is equals to 0 and I is less than n, and then I plus plus. So I will be equal to 0. N, we first have n, which will be the length of the stack, and at this point it is 2. I has been initialized with the value of 0, and let's now begin with the loop. So I is less than n. Is that true? Yes. So let's begin. S that push n, so n will be push 2. All right, so after that the loop is done. We go back to the top. It will be incremented with 1. 1 is still less than n, which is 2, so another 2 will be pushed at the top, and then increment and go back again at the top of the loop. Is I less than n? No, because at this point I has a value of 2 and n has a value of 2. It no longer satisfies our condition that I must be less than n, so the loop will be stopped here, and we will now proceed at the next line of code, which is a while loop. So while the stack is not empty, y will take the value of the pop, or the top of the stack, and it will be popped, and then we will print out y, the value of y. All right, so let's begin. The stack is not yet empty, so let's pop. Y will have the value of 2, and then the value of y, this is the output. Okay, let's say that 2, there will be 2 here. And then new line, going back to the top of the loop, the stack is not yet empty, so y will be popped. The stack will be popped, and y will take its value. So we have 2 here, and then print out y, 2 again. And then next, the stack is not yet empty, there's still 2 here, so the stack will be popped, and y will take its value. So the top of the stack is 6, y will take 6, and we will print out y, which is 6. And then the stack is not yet empty, there's still a last element here, and 2, so the stack will be popped, and y will take its value, which is 2. And then new line, and then next to that, x is plus x. So at this point, x has a value of 6, so it will print out x is 6. So that has been the implementation, or an example, of stacks. So now let's proceed to the application of stacks. One application of stacks is the evaluation of arithmetic expressions. So these are the infix this points, or this so infix refers to the operators in this arithmetic expression, so the plus and the multiply sign. And then prefix, from the word itself, pre, all the operator signs will be placed before. And then lastly, postfix, so here it will be placed after. So let's move on to our next slide. In this next slide, I'll be teaching you how to solve infix, postfix, or prefix problems, but we will not be using the stack method. I hope at this point you already know how stack works, so I'll be teaching you a simple way on how to solve it. So let's say we have this problem. Let's say we're going to choose this one, the first one. 4 times b plus c minus 5. So we first have to solve the postfix. So my technique with that is to use operator precedence and the use of parentheses. We'll be using the PEMDAS method. This will be the operator precedence. So let's say 4 times b plus c minus 5. So since there's a multiplication here, we'll enclose it in parentheses, and then this will be the next one, and this is the last one. So after that, since this is a postfix, we will now move the operators enclosed inside the parentheses at the end. So 4b times, and then next we have c, move it at the end, and then lastly we have 5 and move it to the end. So basically, our answer for the first one is 4b times c that's a terrible multiplication sign, c plus 5 minus. All right, so prefix, you can still, it still applies, you can still use the same method. So let's prefix. So again, we have 4 times b plus c minus 5. Let's enclose them all in parentheses again. Then after that, let's place all the operator signs at the beginning of the parentheses because it is a prefix. So we have here 4b, and then here, and then lastly 5 here. So for this one, our answer will be minus plus multiplication 4b c 5. There we go. So that's the answer for the first line. And then let's say we want to solve, let's pick another one. Let's say we want to solve this one. So for our next problem, let's solve this one. So let's first solve the infix one. So for this one, what I do is I write it down, ABC times plus D minus, and then after that I will be moving these operators at the nearest to the left, two sets of non-operators. So for example, this multiplication sign, its nearest two sets of non-operators is b and c, so I'll move it in between these two, and then the plus sign will be moved here, and then lastly the minus sign will be placed here. So it will look like A plus B times C, and then minus D. So that's how it looks like. Alright? And then from here, to solve the prefix, what I do is I just use this one, the infix, to solve the prefix. Again, after solving the infix, I use it to solve the prefix. So I write it down again, A plus B times C minus 5. And then again, I do the parentheses method using the operator precedence. So let's enclose that, and enclose that. Then let's do it. So prefix, so it will be here B, C, A plus, and 5 minus. So our final answer here will be, oh sorry, this is a D, sorry. So our final answer here will be minus plus A times B, C, D. There we go. And then next, we have this one. Let's solve this one. So again, let's write it down. A times B plus C minus D E. There we go. There we go. So now let's proceed to add some parentheses. We'll be solving postfix. So let's do it like this. Add that, and finally add that. So let's first do this one. So A times B plus C minus D E minus. Okay. And then after that, let's do the rest. So next is this one. So A, B, multiply, then C plus, and then let's put them together, D, E minus, minus. So our final answer would look like, for the postfix, as A, B. AB times C plus DE minus minus. So for the prefix again, I'll write it down. A times B, A times B plus C minus, open parenthesis, D minus E. Alright, again, let's add the parentheses. Yeah, like that. So let's first solve these ones. This is a prefix, so the operators are placed before. Here we go. And then let's solve the remaining. There we go. So our final answer will be minus plus times AB C minus DE. So here we go. Alright, so our next topic will be all about queues. So queues are an ordered collection of items from which items may be deleted at one end, called the front of the queue, and into which items may be inserted at the other end, the rear of the queue. So this one can be explained by the first in first out method. So let's say the queue in milk tea shops or in Jollibee, or in restaurants. So this is how it looks like. So we have NQ, which adds a value to the queue, and the queue, which deletes a value to the queue. And so let's say this is how it looks like. So there we go. So let's say 7, 6, 5. So incoming new data are fed here. Incoming ... However, as opposed to stacks, you don't remove value by going to the top. You remove the values by removing those that came first. So 7 will be eliminated first, and then 6, and then 5, and then so on and so forth. So these are the queue operations. We have init queue, which creates an empty queue, enqueue, that add or stores an item to the queue, the queue, which removes an item from the queue, and peak, which gets the element at the front of the queue without removing it, and then is full, it is to check if the empty is full, and is empty, to check if the queue is empty. So we have this example for the queue. So let's do this. So we are going to NQ 5 we have there, and then NQ 3, but the next one is the Q, so 5 will be eliminated, so it will be now 3 only. However, the next one is 3 NQ 7, so 7 will be added at the end, and then the Q, so 3 will be eliminated and 7. So the next one is front, so the front is 7. Then the Q, 7 will be removed. And then the next one is the Q. However, there's no more value to the Q, so this one will result into an error. Okay? And the next one is empty. So, as I've said, there's no more value inside the Q or no more data. So this will return a true value. Then NQ9, and then next NQ7, and then it will check its size. So the size of the Q is 2, and then NQ3, 9, 7, 3, and then NQ5. And then lastly, the Q, which will result to the 9 being removed from the Q. So our final Q will be 7, 3, 5. That's your Q. So that will be the end of the stacks and queues lesson. So I hope you guys learned something from this, and stay tuned for the other lessons. Thank you and goodbye.